CMOS technology. So you know that nowadays the VLS technology is developing like everything. So our world, that's Taiwan Semiconductor Materials also is producing a lot of semiconductor material. Even we have started the new company for producing the VLSI chip. So within 20 to 35 years, the VLSI is going to lead the world. So we can see the case study how the CMOS VLSI is going to give the fruitful to the society and to the world. We can discuss on it.
Must be compact and fast and has to function and fast. So almost in every systems we can see one common divider, one common component, that is digital clock, which is the backbone of every electronic instruments. Basically, digital clock has to be used in a minimal power to continuously power the entire system. So in today's case study we are going to discuss how efficiently we can manufacture the digital clock using minimal power, and how functionality it can be throughout the circuit, and how it can be maximized by futuristic technologies to power the entire electronic circuit.
So I'm here to talk about the problem statement. In this problem statement we are here to make the digital clock with the help of CMOS, which can show hours, minutes and seconds. So with the help of mod 60 counters we are going to measure the hours and seconds and minutes, and with the help of mod 24 counters we are here to measure the seconds, and the logic gates which is used to reset and transition, and finally we are here to use the CMOS transistor, which is helpful for power efficient consumption.
And then I'm here to speak about the VLSI design flow. First of all, there is two types of design flow. First one is ASIC and FPGA. The ASIC stands for Application Specific Integrated Circuit, and the second one is Field Programmable Gate Array. It is a similar type of process. Only the back-end process may be different. In front-end process, the both similarities are same. The first step is specification. In specification, the customers or vendors define the specs like what inputs we have to be needed and what the clock frequency should be. We collect the specification from the vendors, and then after collecting the specification, it goes to the architecture level. The architecture defines what shape should be the chip and what range clock frequency should be. And then after defining the demo model of a chip, and then the model engineers write the test bits and art inputs on chip models. First of all, the model engineers design a chip by writing a register transfer of coding as a Verilog and VSTL. By writing the Verilog and VSTL, they will check the output of a waveform. It should be measurable value, and if it shows the correct value, means we are going to be process the next step. It's called fabrication. After fabrication, the fabrication process is a very tedious task. In fabrication only we have to be very careful. In fabrications there are many tasks like photolitho process. The photolitho process defines how the chip should be patterned in the silicon wafer. While patterning the silicon wafer, it should be like there is a machine called ASML company. It's a Dutch-based company where all the chip makers depend on one machine company. After doing the fabrication process, we have to check whether it's running properly or not. After running the process, we have to go to simulation. After correcting all the front end tasks, later we come to the back end task. The back end task is nothing but we have to connect the routing process very clean and clearly, because if one wire disconnection means we would be thrown back into the front end task. It's very dangerous, so we have to be concentrate we have to fix the wiring. It's called routing, and then clock frequencies. After fixing the wiring, we have to measure the clock frequencies. It means if the frequency is not come to up to the level, we have to design from the first. So while designing the design flow of any chip or a processor, we have to be very clear.
So I am going to tell about tools used in CMOS technology. There are 4 types of tools used. First one, cadence switcher. So it is used for schematic capture and logic verification. And the second one, spectral simulator. It is used for analog and it is used for analog and timing simulation. And third one, Asura caliber. It is used for DRC, design rule check, and LVS, layout versus schematic verification. And finally, LT space. It is used for initial logic verification before VLSI design. So these tools help us simulate, verify, and ensure that design was power efficient and fabrication.
So here to conclude. So I believe that this VLSI case study gave us a complete understanding about the chip design. So we know how to design using a CMOS logic gate and work according to the industry grade VLSI workflows. Then we know that low power clock is simple, but it's more powerful among them, which is a real-time example. Real-time example of VLSI design we can be used in the future, which gives us more confidence to tackle complex designs in semiconductor, in both semiconductor and embedded system domain. Thank you.
So, there are discussed case study, CMOS technology and VLSI like a fabrication process and ASIC. So everything is very, very important. That the low power VLSI is very, very important. So what we discussed. So VLSI is also is nearing to zero, operating nearing to zero level of voltages. So it will be very useful for the low power voltage and the tiny devices and other sensational devices. So and then like aircraft, so and then space science, that all we are using the VLSI technology, especially the CMOS technology. Thank you. VLSI is from